Exponential functions. Exponential function is a nonlinear function in the form of y equals ab to the power of x, where a cannot equal 0 and b cannot equal 1, and where b is going to be greater than 0. Remember, your independent variables are your x, correct? And your dependent variables are your y, which, just recall, this is also your input and output. Previous lesson, we learned about linear functions. So if you remember, linear functions are constant rate of change. Whereas now we have exponential functions where it has a constant percent rate of change. So we can see that the difference now is that we have a percent, and it's exponential. Remember exponents, when you read the word exponent, that is to the powers. In this example, we're going to identify the function to represent if either it's a linear or an exponential function. If we notice a difference between 0 and 0 and 1 is plus 1. The growth between 1 and 2 is plus 1. And between 2 and 3 is plus 1. So we can determine that x increases by 1. And y, we can see that 2 to 4 difference is plus 2, 4 to 6 is plus 2, and 6 to 8 is plus 2. So y increases by 2. We also could see that there is a rate of change. The rate of change is constant. Therefore, this is a linear function. In B, we're going to do the same thing. Between 0 and 1, you have plus 1. Between 1 and 2, we have plus 1. And 2 and 3, we have plus 1. So same thing as A. X increases by 1. Now let's look at Y. We can say that Y, 4 to 8 is plus 4. 4 plus 8 and 16 is plus 8. And 16 to 32 is plus 16. That is not anything constant. Remember that it's going to be now a what? Constant percent rate of change. So we go from 4 to 2. It's multiplied times 2. 8 to 16 is times 2. And 16 to 32 is also times 2. So here, y is multiplied by 2. This is going to be, the function is going to be a exponential function. In example 2, we're going to evaluate the exponential function. If you recall, the function is going to be nonlinear, and it's going to be in the form of y equals ab to the power of x. Look at A. All we're doing is part 1, you're going to substitute for x. Where we're left at y equals negative 2 times 5 to the power of 3. Part 2, we're going to evaluate the power. So the first thing is, do not multiply negative 2 times 5. You're going to first do the power. And we know that y equals negative 2. And 5 to the power of 3 gives me 125. And part 3, we're going to multiply. Y equals negative 250. In part B, we're doing the same rules, okay? So do not forget the same rules. It's going to be important. Part B, we're going to have substitute for x, which is going to be y equals 3 times 0.5 to the exponent of negative 2. Now it tells us part 2 to evaluate. So if you recall, we have a negative exponent. So it's going to be y equals 3 times 1 over 0.5 to the power of 2. Simplify. 3 times 1 to the power of 0.25. And 3 times 0.25 gives me 12. Okay, core concept. The graph of a function, of your exponential function y equals ab to the power is a vertical stretch. It's going to be a vertical stretch or a vertical shrink by a factor of the absolute value of a. Okay, so if you notice, it is going to be right here, AB. From the parent function, which the parent function is from the parent function, which is y equals b to the power of x. If when a is less than 0, you're going to have a reflection in the x-axis. And your y-intercept will be a from the graph, which is y equals ab to the power of x. So here we can see that we have graphing y equals ab to the power of x when b is going to be greater than 1. So we're going to graph f of x equals 4 times 2 to the power of x. What would the parent be? Remember, the parent is going to be y equals b to the power of x. Here, in our case, b is the 2. Remember, this is a, b, x. So the parent, is going to be y equals 2 to the power of x. This is going to be one graph, okay, which is your parent, and we're going to have a second graph. So the first thing we need to do is do a table. Okay, first thing is create a table, make a table. We're going to use order pairs. We're going to use order pair to graph our exponential graph. But before that, pick order pairs. The best thing to do is, we know that x, let's pick negative 2, negative 1, 0, 1, and 2. Please recall in the previous slides to do the steps of 1 where you substitute for x, and then you evaluate your powers, and then finally you multiply. So in this case, we're going to have 4 when it's negative 2. This, by the way, is the function of x, which this is the graph for this one. So we're going to have 4 times 2 to the power of negative 2. I'm using from this, okay? That's my x. That's where I am substituting. So we know that simplified, this gives me 4. It's a negative. It's going to be times 1 over 2 to the power 2, which gives me 1. So my answer here is 1. When it's 4 times 2 to the power of negative 1, this gives me 4 times 1 to the power of 2 and 1, which this gives me 2. When it's 0, remember, if we recall the rules, anything to the power 4 to the power 2 to the power 0, that becomes 1. And 1 times 4 gives me 4. Then finally, two more. We have 4 to the power times 2 to the power of 1. Anything to the power of 2 gives me the base, right? I mean, anything to the power of 1, I'm sorry. Anything to the power of 1 will give you the base, which this is 4 times 2 gives me 8. And then finally, 4 times 2 to the power of 2, which is 2 to the power of 2 is 4 times 4 gives me 16. Now I have my ordered pairs, and I'm going to, part 2 is, after I made the table and I computed everything, I'm going to plot. So the first one, I'm going to have negative 2 and 1, which will be right here. Then I have negative 1 and 2, 0 and 4, 1 and 8, 4, 5, 6, 7, 8, and 2 and 16. 8, 9, 10, 11, 12, 13, 14. It's going to be somewhere over here that I'm way outside the graph. If a graph, always remember this equation, okay, this formula, this equation, whatever you guys want to call it, but it is really a exponential function, okay? A function approaches the y-axis, but never intersects, okay? It approaches, but never intersects. So I'm going to have, like, graph it, I'm going to have some, ooh, this is bad. This is f of x equals 4 times 2x, correct? Now my parent, where's my parent? My parent, we established, is above, b is greater than 1, correct? B is greater than 1, which is 2 in this case. So I'm going to have, goes to 1, goes to 2, and it's a crooked line. But I can tell that this is my parent, which is y equals 2. We could use y, or we can use the parent, which will be g of x equals 2 to the power of x. If you put y equals 2 to the power of x, it's perfectly fine, as long as you guys know the difference. This is parent, and this is what we computed. What can we tell in this graph? We can tell in this graph that we just functioned that this is a vertical stretch. Vertical stretch. Correct? How do we know it's a vertical? By a factor of what? By a factor of 4. Because this is where it meets at 4, right over here. Okay? It's stretched at 4. When, what else can we tell? The y-intercept of the graph is 4. We also can know that the domain is going to be all real numbers. And the range is where? The range is going to be y, because this is above. The blue line, which is the one we computed, is above the parent. Okay, so y is greater than 0. So before we had where b is greater than 0, our line ones were going this way, correct? Posted. Now we have where 0 is less than b and b is less than 1. So now our lines are going to go the opposite way, because it is now, what do you guys think? Let's look at what it is. I already know that this is y equals ab to the power of x. My a here is who? My A is negative what? My A represented by a negative sign, correct? Because we have f of x equals negative half to the power of x. We know that A is represented by a negative. B is who? Half. So this is A and B. Therefore, if we notice here, now we can tell which is our parent. Our parent is going to be y equals half, which is our b, to the power of x. Okay? We also can name it g of x, because it's a function, half to the power of x. Okay? So let's do a table now. We're going to have a table, and our table is going to be, I'm going to use the same points. Let me move to yellow. Have negative 2. This is x. And I have negative 2, negative 1, 0, 1, and 2. And this is f of x. Remember, this is our new formula, which is negative half to the power of x. If we use negative half, we already know that this has to be translated completely, right? We have negative half to the power of negative 2. This is a negative exponent, so switch it to a positive exponent, which gives me negative 2 over to the power of 2 for 1 to the power of 2. You distribute. So I'm going to have now negative times 4 to the power of 1, which that gives me negative times 4 over 1 gives me negative 4. Okay. If I do the same thing, but now with negative 1, I'm going to have negative times half to the power of negative 1. Simplified, that's going to give me negative 2 to the power of 1, 1 to the power of 1. And we know that that's the base. So my answer is going to be negative 2. Because negative times 2 gives me just negative 2. Wait, negative 2. Let me erase that by mistake. And now we're going to have to the power of 0. So our answer here should be, remember your rules. If we have negative times 1/2 to a power of 0, we know that this becomes just what? 1. So 1 times negative 1 gives negative 1. If we have let me just erase it completely. Now if we have negative times half to the power of 1, everything with the base. So my answer is going to be negative half. And now we have negative half times 2. That is going to give me, distribute, remember, negative 1 to the power of 2 and 2 to the power of 2, which gives me negative 1/4. I'm able now to graph. So after attaching a graph, I'm going to start plotting my ordered pairs. So I have negative 2 and negative 4. Negative 2 and negative 4. 1, 2, 3. Oops. I need this. Negative 2 and negative 4. Let me do this color. We're going to have negative 1 and negative 2. I'm also going to have 0 and negative 1. 1 and negative 1. Oof, this is going to be very tight. So the point's going to be halfway here, and the other one halfway here because it's 2 and negative 1/4. Okay, if I was to do my line, I'm going to start with somewhere. Okay, remember, it approaches, but it doesn't touch. That is my who? This is f of x equals negative 1/2 to the power of x. And then finally, now we could do our parent. And who's our parent here? Parent is 1/2 to the power of x. Let me put red. So I know that 1/2 is going to be where? We're going to approach there where the 1 . Okay, so this is our parent with this g of x equals 1/2 to the power of x. So we kind of can see that this is a what? Reflection on the x-axis. We can also tell that the y-intercept is -1 based on my new equation, right? My new function, which is -1. And we have, because now this is who? Below. Remember, our parent is above and the new function is below. So the y-intercept of the graph of g, okay? -1 is below. So from the graph of f, you can see the domain. This is f. The domain is all real numbers. And the range is who? The range is y is less than 0. Okay, because it is below. Graphing y equals ab to the power x minus h plus k. So the first thing you want to do is start by graphing y equals ab to the power of x. Then translate the graph horizontally. Okay? Horizontally. Then it's going to translate horizontally h units. Okay, h units. And vertically k units. Okay, so h always remember for horizontal and k for vertical. So here we have the graph of y equals 4 times 2 to the power of x minus 3 plus 2. So here we know that minus 3 is going to be my h units, which horizontally, and my k units is going to be vertically. Translation. Okay, we're doing translation. So first, let's input a graph. If you recall, in example 3, we had y equals 4 times 2 to the power of x, which that we had lines what? We had 0 and 4, and we had 1 and 8. So we had those points. So let's graph that first one. We're going to have where we had 0 and 4. This is going to be, remember what it says. First, you're going to graph, okay? This is first. We're going to graph y equals mx ab plus x. Then we'll do basically this right here, which is our horizontally and vertical translation. So here we're going to use, from example 3, the same graph. But we had point 0,4, which is right over here, 0,4, which was our y-intercept. And we had 1 and 8. 4, 5, 6, 7, 8. And then we'll recall that was very close to the x-axis, but it did not touch. So that is going to be y equals 4 times 2 to the power of x. That is based on our first. Now we're going to do what? On step 2. That is first step. Step 2, we're going to translate the graph 3 units to the right. Okay, 3 units to the right. From the given, okay? From it was given to it. And we're going to do 2 units up. Now we're going to pass through the, well, we're going to graph our new line. Let me use the blue. So we know we're going 3 units to the right. So we're going to go from 0, 4. We're going to go 1, 2, 3 units and 2 up. 1, 2. So that is going to be our new point. So everything is going to be 3 units to the right and 2 units up. So we're moving basically from that actually intersects, right? So we're going to have y 4 times 2 to the power of x minus 3 plus 2 units. So what can we tell with this relationship and everything we hear? We see from the first one, we have translated. So the graph approaches the line where y equals 2, correct? It approaches where y equals 2. What else? This is where 2 is at, okay? We could say it approaches, but it does not intersect, okay? It does not intersect. What else can we see? The domains are all real numbers, and my range is where y is greater than 2. So if we see here, you can see where y is going to be greater than 2. Linear or exponential function. We know that between 0 and 1, it's increasing by 1. 1 and 2, it's increasing by 1. So we know that x is increasing by 1. What's happening to my y? My y, I know that this is 8 to 4. It's actually decreasing, right? But it decreases by what? Minus 4. Let me erase this so we can see it. So this is a minus 4, but then this is a minus 2, and this is a minus 1, right? But we also can see that this is being split by half, correct? So this is multiplied by half, because 8 times half gives me 4, and 4 times half gives me 2, and half of 2 gives me 1, correct? So here, this is an exponential function where x increases by 1 and y multiplies by half. Okay, now let's look at number 2. Number 2, we know that this is negative 4 to 0 is plus 4. 0 to 4 is plus 4. And 4 to 8 is plus 4. So this is an increase of x by 4. And y, we know that it's from y to 0 is minus 1. From 0 to negative 1 is minus 1. And negative 1 is to negative 2 is minus 1. So we could see that y decreases by 1, correct? So this is a constant rate of change. This is going to be a linear function. In 3 or 4, we're going to evaluate where x is negative 2, 0, and half. So my answers are going to be y equals 2 times 9 to the power of negative 2, y equals 2 times 9 to the power of 0, and y equals 2 times 9 to the power of half, correct? So let's work this out. We know that this simplifies to 2 times 1 over 9 to the power of 2, which does gives me 2 times 1 over 81. And that's my, and what is 2 times 1? 2. So my answer is going to be for this one 2 over 81. In my second one, we know this becomes 1, so my answer is going to be 2. And 9 times half gives me what? And then finally, 9 to the power of 1/2. So if you recall, this is going to be with the radicals, right? This is going to be 2 times power of 2, the radical of 9, which is the square root of 3, correct? This becomes 3. So my answer is 2 times 3 is 6. In the second one, we're going to have y equals 1.5 times 2 to the power of -2. Simplified, this is going to be y equals 1.5 times 1/2 to the power of 2, which gives me 1.5 times 1/4. So what's my answer here is going to be 1.5 times 1.5 times 1 gives me 1. Divided by 4, I'm going to get 0.375. That's when it's -2. When I have y equals 1.5 times 2 to the power of 0, we know that this becomes 1. So my answer is 1.5. Then finally, when I have y equals 1.5 times 2 to the power of half, gives you y equals 2.12.